simplify this. This.
Would it be root 21?
Indeed, square root 21. So when you multiply two things like that, you can put you can do the multiplication and then put one square root over it all. What about this?
Would that be root 7?
Yes. Here's one.
Would that be 7?
Oh, how do you get 7 straight away?
It because the square root of 7 times square root of 7, well, the square root of a times square root of a is a.
Oh yeah, in general, square root of a times square root of a is a, or if you like, the square root of 7 squared, squaring and square rooting cancel each other out, so it just gives you 7. Nice. Yeah, those are the main things we need to know. And now we're just going to apply that to things like this. So on the second slide, it works just like expanding brackets.
Would that be root 6 add root 4?
Indeed, root 6 add root 4, because root 2 times root 3, and then root 2 times root 2. But what is root 4?
2.
Right, so we can write it as root 6 plus 2. All good so far?
Yeah.
Cool. Okay. Let's do this. Yeah. It took me a while to come up with that question.
Would it be root 21 add root 21 add root 196?
Okay. And then this, believe it or not, can actually be simplified. The 196 has a square root. It's got a nice square root, should I say.
Is it root 21 add 14?
Sorry?
Add 14.
Yes, the square root of 196 is 14. So square root of 21 plus 14. So now, because this looks weird, because this one, we didn't have a situation of a number square, like a number times itself. So why might we have gotten a number like that? Well, before we can answer that, we first of all need to look at applying the multiplication rule in reverse. So let's look at the square root of 8 as an example. If you applied the multiplication rule in reverse, would we agree? In fact, what two numbers can you think of that multiply to give 8?
2 and 4.
That sounds good. So square root of 4 times the square root of 2. Those two things multiply to give 8. So therefore, we can say that that is true, this relationship that I've just written on slide 3. Does that make sense?
Yeah.
Then, the square root of 4, what is the square root of 4?
2.
Right, so you can write that as 2 times the square root of 2. The square root of 8 is the same thing as 2 times the square root of 2. So, using that same kind of logic, how might we simplify the square root of 27? Of course, you can think about this.
The square root of 9 times the square root of 3, which is 3 times the square root of 3.
Indeed. So give me a moment. So yeah, the square root of 27 can be written as the square root of 9 times the square root of 3, which is equal to 3 times the square root of 3. So you don't have to put the times in between because it's implied already. Here's one. The square root of 50. Now let me ask you a question. If I were to write the square root of 50 is the square root of 10 times the square root of 5, which it is, what is that useful to me?
No,
Why not?
because you can't simplify square root of 10 times square root of 5.
Yeah, there's no, like, none of these are square numbers, basically. None of these can be square rooted easily. Now, there are other ways in which we can do this, but I think one, like the direct way, a nice direct way would just be to find a factor that's a square root. So what two numbers would be better to split it into instead then?
25 and 2.
Yes, because 25 is a square number. So we can write the square root of 25 times the square root of 2.
5 times root 2.
That's it. So I'll just give you a few more to try.
I have the answers.
Are you done, did you say?
Yeah.
Nice, okay. So let's see. With 75?
I got 5 times the square root of 3.
Yes, because it's the square root of 25 times by the square root of 3, which is 5 times the square root of 3. Nice.
For the second one, I got 2 times square root of 5.
Nice, because it's the square root of 4 times the square root of 5, so 2 square root 5.
The third one, I got 4 times the square root of 2.
Nice, because it's square root of 16 times the square root of 2, which is 4 times square root 2.
The fourth one, I got 4 times the square root of 3.
Nice, so you recognize that 48 was the square root of 16 times the square root of 3, which is 4 times the square root of 3.
And then the last one, I got 10 times square root of 2.
Nice, because it's square root of 100 times the square root of 2, which is 10 square root 2. Good stuff. I'm guessing, well, yeah, you got those. Was it quite hard to get those questions, or not so much?
Not too much.
Okay. Like sometimes we can get into this kind of situation where we need to simplify these. So, in fact, let me show you one example first. Imagine I wanted to simplify this. So still on the same slide. 3 times the square root of 45. Well, it's the same thing. It's just recognizing that there's a 3 there as well. So that's the same thing as 3 times 45 can be written as the square root of 9 times the square root of 5. We want the square root of 9 aspects there because 9 is a square number. So that's 3 times, well, the square root of 9 is 3. And then that's times by the square root of 5. So we end up getting 3 times 3 is 9. So that's 9 times the square root of 5. Does that make sense?
Yeah.
So then how will you go about doing this one?
you would do 10 times square root of 4 times square root of 2,
Nice.
which is 10 times 2 times square root of 2,
Yep, which is 10 times 2, because the square root of 4 is 2, times the square root of 2. Yep,
which is 20 times the square root of 2.
that's it. So, yeah, that's how that one works. I think these ones should be fairly quick because some of them you may have done already. And then it's just a case of multiplying it by the 5. So it's on slide 5.
I've got the answers.
Nice. Okay. Let's go through. So first one.
For the first one, I got 10 times square root of 2.
Nice, because it's 5 um, square root 4 square root 2. 5 times 2 square root 2. 10 square root 2. Nice.
For the next one, I got 4 times square root of 5.
Looks good. So that's 2 times square root 4 times square root 5. 2 times 2 times square root 5. So 4 square root 5. Yep.
For the next one, I got 20 times square root of 2.
Okay, so that gives us 4 times square root 25 times square root 2. 4 times 5 times square root 2. So that's 20 times square root 2.
For the next one, I got 21 times square root of 2.
Yes, because that's 3 times square root 49 times square root 2, which is 3 times 7 times square root 2, which is 21 square root 2.
The last one, I got 50 times square root of 3.
So 15.
50. Oh,
Okay,
wait.
so 15 times. What did you get the square root of 32 to be?
Um, I think I might have skipped one by accident.
Okay. All right, so we'll do F first. So 10 times the square root of 25 times the square root of 3. And then that's 10 times 5 times the square root of 3, which is 50 square root of 3. That's the one that you did, right?
Yeah,
Cool. And then I guess we can think about E then.
I got 60 square root of 2.
Nice, yeah. So square root 50, so 15 is times the square root of 16 times the square root of 2. 15 times 4 times the square root of 2. That's 60 square root 2. Cool. Now one more extra step of progression. It comes to, but I'll go on slide 5. Let's imagine we wanted to do 5 square root 8 plus 4 square root 50. I've purposely picked these ones because we've already simplified these. So from above, 5 root 8 simplifies to 10 root 2. 4 root 50 simplifies to 20 root 2. And then if you treat this like it were 10x plus 20x, because they both have root 2's, then you'd get 30x or 30 lots of root 2. Does that make sense?
Yeah,
Okay, so then how would you simplify 3 square root 98 plus 15 square root 32?
first you would simplify it to 21 square root 2, and then 60 square root 2, and then you would add them together to get 81 square root 2.
That's it. So the first one we got from this part was 21 square root 2. Next we got from this part 60 square root 2. And as you said, 81 square root 2. So yeah, that's pretty much how that one works. So here are 4 questions to try. I think you will get familiar. Some of these are quite familiar now in terms of the way in which you'd simplify them because we've done them a few times before. But can you work out the following additions/subtractions?
I have the answers.
Cool. Okay. So
For the first one, I got 5 root 2.
yep, because the square root of 8 is root 4 root 2, which is 2 root 2. Square root of 18 is root 9 root 2, 3 root 2, so that's 5 root 2. Nice.
Then the next one, I got 7 root 2.
Sounds good. So square root of 50 is square root 25 square root 2, which is 5 root 2. Square root of 8 is square root of 4 square root of 2, which is 2 root 2. That gives us 7 root 2.
The next one, I got 8 root 3.
Okay, so the square root of 75 is square root 25 square root 3. And the square root of 27 is square root of 9 square root of 3. So that's 5 times the square root of 3 plus 3 times the square root of 3, which is 8 square root of 3.
The next one, I got 6 root 2.
Okay, so the square root of 200 is the square root of 100 square root of 2. Square root of 16, sorry, square root of 32 is the square root of 16 square root of 2, which is 10 root 2 minus 4 root 2, which is 6 root 2. Nice. And then finally, well, not finally actually, but the next step will be to carry out expansions with double brackets. So on the next slide, here are 3 such questions. And using our knowledge that we have attained for expanding double brackets with x's, this works the same way. So can you see it on slide 7?
Yeah.
Yep. So we've got 2. That's multiplied with this 1, which gives us 2. We have 2, which is multiplied with the square root of 3, which is plus 2 square root 3. We have root 3 multiplied by 1, which is plus 1 square root 3, if you like, or just square root 3. And then we also have root 3 multiplied by root 3, which is root 9, which is 3. And then the next part is just a simplification. So 2 plus 3 gives you 5. And then this 2 square root 3 plus 1 square root 3 is going to give us 3 square root 3. So that's what this simplifies to. So could you tell me how we would do the next one?
First, you would do square root 2 times square root of 1
Yep.
times 1, which is square root of 2.
Yep.
Then you would do square root of 2 times square root of 2, which is 2. And then you would do 5 times 1, which is 5.
Yep.
And then 5 times square root of 2, which is 5 square root of 2.
Yeah. And then the simplification.
And then would you do 7 add these. 6 square root of 2.
Perfect. 2 plus 5 gives you 7. And then the square root of 2 and 5 times the square root of 2 is 6 times the square root of 2. So there we go. That's it. And then, could you have a go at the final one?
Would it be 7 add 5 root 3?
Okay, so let's go through it. So we've got square root of 3 times square root of 3, which is 3. Square root of 3 times 4, which is 4 root 3. 1 times square root of 3 is 1 root 3. 1 times 4 is 4. And you said 7 plus 5 square root of 3, indeed. Okay. We'll do one more sort of boring-ish one, and then we'll get to one that's a bit more exciting. So, how might we do this?
Would you write out as 2 add square root of 3 times 2 add square root of 3?
Indeed. So this is identical to 2 plus square root of 3 multiplied by 2 plus square root of 3. And then you carry out the same procedure. So 2 by 2 is 4. 2 by root 3 is 2 root 3. Root 3 times 2 is, again, 2 root 3. Root 3 by root 3 is 3. That simplifies to 7 plus 4 root 3. Okay, so I've got another question for you. And that's this. Something squared, and my final answer is 6 plus 2 root 5. What could my thing have been? So with this one, you might have to try a few different things before getting it. And when you've got an answer, I just want you to have a think as well about like what logic you applied to get that. So initially your guesses might be random, and then you might realize, oh, hang on, this definitely wouldn't work because this might work because, and so on. Cool. Just to check to see how you're getting on. So just out of interest, what was your first guess?
First, I tried 3 add square root 3 times 1 add square root 3.
Okay, hold on. So first of all, let me just write the question again on the new page. So it was something squared, and the final answer was, oh dear, 6 add 2 root 5. So your initial guess was what, sorry?
First I did 3 add square root 3 times 1 times square root 3, but now I realize it's not a square.
Okay, yep. So yeah, the brackets that you should be multiplying out should be exactly the same. Hopefully that helps you narrow down the number of guesses that you're looking at. Okay, so just checking again. Now that you know it's squared, what kinds of guesses have you been using?
I've been trying to do I've been trying to work backwards, so 3 add square root of 5 add square root of 5 add 3. So I've got the start of it, which is square root of 3.
Okay.
I'm not too sure what to do next though.
So you said, so you tried to work it backwards by going, say that again, 3 add.
Square root of 5 add
Mhm.
square root of 5 add 3.
Oh, I see. And then you said
The start of it would be square root of 3. But
possible. Well, if okay, can we say one thing? Maybe could we maybe agree that somewhere in this we're gonna have to have square root 5? So square root of 5 in some way, shape, or form is going to be involved, given that the answer has square root 5 as well. Does that make sense?
yeah,
So why don't you maybe try a guess now, just a number plus something times square root 5 and see what you get there, and see if you can tweak things to make it bigger or smaller or get closer to the answer. Does that make sense?
yeah,
Cool. This is a hard task. It's not a kind of task that you would necessarily get in a GCSE paper, but I think it's just good for practicing your expansion, but also just thinking about how these results come. So question, what now knowing that it's going to have a square root 5 in it, what did you try?
I've been trying to do something minus square root of 5 squared.
Okay, so what did you try?
Um, at at first I tried doing it as the square root of 64, but that didn't work.
What about just like a
But
whole number? Just a normal whole number. So maybe guess a whole number minus the square root 5.
um, 2,
Okay, so let's go. So you want to do 2 minus the square root 5, is that right?
yeah,
Okay. So that's 2 minus the square root 5 times 2 minus the square root 5, which is 2 times 2 is 4. 2 times minus root 5 is minus 2 root 5. Minus root 5 times 2 is minus 2 root 5. Minus root 5 times minus root 5 is plus 5. So this one gives us 9 minus 4 root 5. Not bad, but notice how in the answer that we want, it's got a plus, and in our one, we've got a minus. So how could we adjust our answer so that we don't have the minus anymore?
we could make the whole number a negative.
What as in minus 2?
Yeah,
Yeah, we could do that, I guess. So minus 2 minus root 5 instead. Okay. Oops. So minus 2 minus root 5, and we want to square that. So that's minus 2. Ooh. So we'll make that minus 2 minus root 5 times minus 2 minus root 5. Okay. So the minus 2 times minus 2 is 4. Minus 2 times minus root 5 is plus 2 root 5. Minus root 5 times minus 2 is again plus 2 root 5. Minus root 5 times minus root 5 is plus 5. So this one gives us 9 plus 4 square root 5. Not bad. But our numbers are a little bit big now. So we want 6 plus 2 root 5, but here they've got 9. Here we've got even 9 plus 4 root 5. So how could we further adjust our guess?
I'm not too sure.
Well, if you want smaller numbers as an output, how can we change our input?
we can make the input smaller.
Okay, so how can we change it then? What are we going to make smaller in our initial point?
We can make the -2 smaller.
Okay, to what number?
Um,
I mean, there aren't many numbers. I mean, if we're talking about the magnitude, the size, as in the distance from zero, there aren't many numbers that are below -2.
-3.
So it's -3 is technically below -2. You're right on the negative number line. But if you were to take -3 and like multiply that by itself and everything, you'd end up getting bigger numbers. Does that make sense? Because you end up getting -3 times -3, which is 9. And that's going to result in bigger numbers. But we don't want bigger numbers. We want the result to be smaller.
-2.
So we've already got -2. So that would leave,
-1.
we could try -1. So let's try that one and see what happens. I'll let you try that and
I got 6 add 2√5.
okay, so that seems to be the one that worked. So -1 times -1 is 1. 1 times -1, sorry, times -√5 is plus √5. -√5 times -1 is plus √5. -√5 times -√5 is plus 5. That gives us 6 plus 2, 5. So hopefully this has taught us a bit about adjusting our guesses. But if not that, then you've gotten a lot of practice with squaring brackets and expanding out brackets, which was the whole point of this lesson. So that's good. And of course, there was like another harder task to try. So there we go. Nicely done. If we continue doing any more work on surds next week, then I think a next natural step would be to look at rationalizing within